So far, we have been learning how to solve four equations with one variable. But what happens when we include more equations and more variables, like what we can see on the screen right now? The very first thing we have to do is to make sure we can actually solve this problem. And for this, we count the equations. So 1 and 2, we have two equations. We can have more equations, but in this example, we only have two equations. So let's write it down. Two equations. And then we count the number of variables that we have. So let's count them. We have x. Yes, even though we have a couple of x's, it's the same x. It's just on different equations, but it's the same x. So it counts as only one. So one variable, same thing with the y's. We have a couple of y's, but it's the same y in just different equations. So the y is a second variable. That means we have two variables. So let's write it down. And this is a very important turning point. The number of equations must always be greater or equal than the number of variables. If we happen to have more variables, then we cannot solve this problem. That's why this is the very first check we do on these problems. In this case, we have two equations which is equal. As long as it's equal or greater than the number of variables, we're good. We can solve. So we can proceed. There are a few methods that we're going to learn how to solve the linear system of equations. And by the way, it's called linear system of equations. Remember, linear means the variables have an exponent of 1. The first method we're learning is the substitution method. For the substitution method, first thing we're going to do is we're going to put them horizontally. We're going to need a lot of space. And we need to pick one of the two equations to solve. In this case, let's pick the left equation. It seems a little bit easier. And this looks kind of like a two-step linear equation that we learned in lesson 3.2. So let's solve. But what do we solve for? We need to solve for one of the variables. We either solve for x or for y. Let's solve for y in this case. Well, to solve for that y, let's first make it a positive y. We can't really solve when the variable is negative, so we're going to do a positive y on both sides of the equation. That way we can cancel the y's on the left. And we have 9 plus y on the right. 9 plus y, we can't really do that. So we just write it as 9 plus y. And then to isolate the y, we have this positive 9. So we have to do minus 9 on both sides of the equation. That way we cancel the 9's on the right and minus 9 on the left. Same process we have been doing with equations all the way. And then we do 2x minus 9. 2x minus 9 is simply 2x minus 9. And that's it. We solve for the first variable. Well, we didn't really solve. We make it into an equation. The y is fully isolated, so we're going to call this equation 1. Once we have isolated the first variable, it could be x, it could be y. If we have more letters, it could be any other letter. But once we have isolated one of them, we call it equation 1. It's just for reference, just so we can follow the steps that we're doing. And now that we have this equation y, we can move on to the next equation, to the right equation. We haven't done anything with this yet. And in this right equation, let's look at this. We have 3x plus 4y. 4y. We have a y in this equation, but if we look at equation 1, we also have a y on equation 1. We actually have that y is equal to something on equation 1. On equation 1, it says that y is equal to 2x minus 9. So if y is equal to 2x minus 9, everywhere that we see a y, we can replace it for it. Because when some things are equal to each other, we can replace them and interchange them every time we want. So we can take this 2x minus 9 and we can replace it for the y in the other equation. That's why it's called the substitution method, because we're substituting one of the variables for the other. So let's do that. Let's take the 2x minus 9 and place it for the y in the other equation. And now here on the right, we have an equation with just one variable. We learned how to solve these ones. And we learned that when having a parenthesis, we have to distribute it. So let's distribute the 4 inside of the parenthesis. So 4 times 2x, which is 8x, and 4 times negative 9, which is negative 36. We no longer have the parenthesis. Now we have the 3x plus 8x. This is combining like terms. We can review Unit 2 if you forgot how to do them. But remember, combining like terms is just adding them. So 3x plus 8x is 11x. This is a two-step linear equation. We learned them in lesson 3.2. We start with a negative 36. The opposite of a negative 36 is an addition 36. They cancel, but if we do it on one side, we have to do it on the other. Then 8 plus 36 is 44. And finally, we divide by 11 because the 11 is multiplying the x. We can cancel the 11s, but we also have to divide by 11 on the right side. 44 divided by 11 equals 4. And we have an answer for x. X equals 4. The problem is not over yet because we also have a y. We now need the value for y. But at least we already know what x is. And let's look at this. We have x equals 4. And in equation 1, we have an x. We have 2x. So what we said is, if we already know something is equal, we can replace it, interchange it every time we want. So if x equals 4, we can substitute it for the x in equation 1. So let's do that. We replace that x for a 4. And let's not forget this is a multiplication, so let's put the little dot. And after this, it's just PEMDAS. 2 times 4 is 8. 8 minus 9 is negative 1. We have values for both of the variables. So these are our answers. Y equals negative 1, x equals 4. And this is called the substitution method because we substituted one of the variables for the other until we have a solution.